person in our facility that even knew what they were talking about when they said solar storm warning. So that's how out of touch everybody is with solar radiation. The key here is to understand it and know what it is. That's a sample warning from the Space Weather Prediction Center. We won't get into that. January 24th, S3 solar storm warning. This is the paper from that day, Fox News. Delta reroutes planes following massive solar eruption. Okay, and that was an S3 storm. And this is the Space Weather Prediction Center website. And whose head is that? Okay. So we had to reroute aircraft, and you know, this is reality. This isn't just some egghead's lecture. We really had to do this because it was too dangerous to fly in the northern latitudes because of solar radiation. Let's go to the next one. Well, I'll tell you that one. If the storm is R3, S3, or G3 or higher, you can see most airlines will not allow you to fly on northerly routes, polar routes. You know, it's shorter to get from here to Moscow by going over the North Pole than it is to go west to east. Did you know that? Airplanes, it's a lot shorter to go over the poles than it is to fly, you know, directly there because of the way the Earth's shaped. But when there's a solar storm warning, if you go over the poles, you'll get fried like a, you know, Pop-Tart in a microwave. So you don't want to do that. This is a picture of the flare that caused that warning. My program is called the Charley Bates Solar Astronomy Project, and my name is Stephen Rampton. Charley Bates was a controller that worked with all of us, who's dead now, and he was everybody's good friend, so we named the program after him. But that's the actual picture of the flare that caused the warning, and this white area is hot on the sun's surface. The brighter the color, the hotter the plasma. And I watched this with a bunch of kids at St. Peter's Claver School in Atlanta. Claver, maybe? It's a Catholic school down in South Atlanta. And we watched the flare actually go off. So we saw it before anybody saw it. And that's what my program does. And I wish I had my telescopes here and could show this to you, but you know, maybe you'll get to see it some other time. We won't go into that. That whole slide means that basically radios go out when there's a big solar storm. That's another problem. If you're flying in an airplane and there's a big solar storm, all of a sudden you lose all your radios and navigation. It's going to be tough to find home in that airplane because you're at 45, 50,000 feet. And you can't really navigate by landmarks or anything because you're so high. Solar variability also causes weather. Did you see that storm that just came through? Let's do it again. This storm happened in December of last year. And down there is where we live. And as you can see, this little front that came through, that was pretty dangerous. There was about, I think there was 11 tornadoes. This is in December, if anybody remembers. Y'all all live around Atlanta, right? Yeah. Oh, you don't? Some of you from out of town? Well, it's very unusual for us to have 11 tornadoes in one night down here. We have one or two every now and then, but 11 in the same night is very unusual. And that happened back in December, and it killed a couple hundred people. Okay, and that's very strange. Extreme weather is caused by solar variability. The sun controls everything on this planet. Energy from the sun is what causes weather. Okay, everybody knew that already, right? The atmosphere absorbs that energy, and it causes weather to get more extreme. So this year, where we live, we didn't really have a winter this year, if y'all remember correctly. We didn't have any snow or ice or anything. Georgia, we usually have at least a week's worth of snow or ice sometime in the wintertime. We didn't have any of that this year. It's probably going to be an extremely hot summer. So these extremities in the weather are caused by solar radiation and variability in solar radiation. Like I say, we're in a solar maximum right now, and that's why we're having such extreme weather. Okay? On to the next slide. Extreme weather map brings climate change home. Is anybody in here a global warming aficionado? Is anyone into all that stuff, global warming and being green and protecting the environment? Well, that's good. I can't give you 100% accuracy on this, but I can tell you I'm very educated and learned in the field of solar astronomy. And global warming caused by man is a tiny, tiny, tiny fraction of what's causing global warming. Global warming is actually happening. The climate is heating up, but it's being caused by the sun. Okay? We're not helping anything by throwing those Snickers wrappers outside and dumping our motor oil in the garbage. We're not helping anything in our environment by being polluters, because human beings are nasty, polluting animals, and we're destroying our own planet. But the thing that's causing global warming is the sun. We're not helping, but we're not the major cause of it. Okay? Let's go on to the next one. These are the northern lights, and when I was in the Navy, we were at the North Pole a lot with the submarine, and you could see these northern lights, and if you stand in them, you don't even know you're in them because they're so thin. But if you're 100 miles away, you see this big sheet of just shimmering lights. And what this is solar radiation coming in through the magnetic field, energizing the atmosphere. And the different colors represent the different gases in the atmosphere, because different atoms glow at different colors. Does anybody know what gases are in our atmosphere? Nitrogen is one of them. Very good. Most of it's nitrogen. What else? Carbon dioxide. Oxygen. Oxygen. Thank you. We breathe oxygen, right? You know what most of the atmosphere is? Anybody know what most of it is? Water vapor, actually. All the nitrogen and oxygen is encapsulated in water vapor in our atmosphere. You're breathing water right now. We're not breathing liquid water. We're breathing gas, water gas, right? Vapor. Just like a fish, though. We're breathing in water. We're extracting oxygen from it, exhaling carbon dioxide and nitrogen. That's what we do, just like a fish. A fish lives in liquid water. We live in gaseous water. Yes?
So, like, when basically that energy from the sun hits the element, it gives off a color.
Yeah. Yeah, if you...
Each element has a different color.
That's right. And if you ever heard of a spectrum, or in chemistry class, sometimes they'll burn a certain type of gas like magnesium or oxygen. It'll burn at a different color. That's how you identify atoms in stars and in the sun. You take a spectrum of the atom and you see what colors are caused by igniting the gas. And that tells you exactly what atom you're dealing with. The sun has a certain spectrum that's caused by hydrogen. When hydrogen burns, it looks red. Okay? When oxygen burns, it looks green. So that's just part of chemistry. And you can tell what atoms are what in stars by gathering starlight, looking at the spectrum of the atoms in there, and you can tell what the star is made of. Does anybody know what most stars are made of, mainly? Yeah, but what kind? What's the most popular element in the universe? Hydrogen is the most popular element. Almost everything is made of hydrogen. Us being made out of carbon and iron and stuff, we are extremely rare in the universe. Okay, almost 99% of the universe is hydrogen atoms. Stars take those hydrogen atoms, just like we talked about, and combine them into larger atoms like helium, oxygen, nitrogen. And then everybody ever heard of a supernova? A supernova is when a star explodes, and that's what creates complex molecules like gold, platinum, silver, iron, things like that. Those are all created in supernova explosions. But that's a whole other story. We'll keep on this subject. I could talk to you forever, but I know you won't stay awake very much longer. See this blast right here? This is something we saw through my telescopes at a school. That blast is almost a quarter of the sun blowing off the side. These are solar flares, the white areas. The things that blow, by the way, the Earth is about a third of the size of this laser pointer in comparison to the sun. So as you can see, that blast would have completely vaporized the entire planet and everything around it. But these are blasts that are happening right now. This happened in June 2011. And we watched that blast go off. I live in Virginia Highlands, which is a neighborhood in downtown Atlanta. And I watched that with a bunch of 5th graders. And everybody was pretty impressed with it. That's the kind of events that are going off right now in this solar cycle. Here's some other things that happened this past year. Now, I don't know how nerdy you guys are, but I'm pretty nerdy. And this is cool, okay? And you can act cool later, and y'all can talk all that cool stuff. But right now, this is about as nerdy as it gets. And there's nothing cooler to me than looking at the sun and what it does with the hydrogen plasma that it has. This is all being controlled by magnetic field lines. See those curves and arcs? It's just like in school when you put iron filings next to a magnet and it causes the little curves to happen. That's what the sun does. It's just a big magnetic field. And these are sunspots that are churning along the surface of the sun. Again, the Earth is probably the size of this laser pointer in comparison. This is going on all the time on the surface of the sun. Flares, like these bright areas, a lot of people think that flares are the things that shoot off the sun. That's not true. Flares are the bright areas on the surface of the sun that are caused by magnetic fields interacting. The things that come out of the flares, that everybody usually calls flares, are actually called prominences. And that's just a piece of the sun that's being blown off into space. Well, that's pretty cool if you ask me. And since you are asking me, I'm going to tell you again, that's pretty cool. Again, this dot and that dot and that dot are not part of the presentation. This is a magnetic field telescope that shows you positive and negative charges on the sun.